Hello everyone, welcome. This is the lecture of the class ECE 350. Because the weather condition, the big snow, so today we have the class online. I record the class right now, and then you can see in the YouTube. I will post the recorded video in the YouTube. Okay, let's just start. Today we will consider the Laplace transform. Last time we have given the definition, and also we studied the tables, right? Laplace transform. Now we know the definition. We start from signal of t. By Laplace transform, we have a function of s, which equal to the integration of f of t times e to the negative st dt. Right. So after the transform, we have function of s. Now here's s. T is used in the integral. All right. Now we have two tables. We can find the Laplace transform by definition or by the tables. Now we can consider some examples. Like f of t equal to 3t e to the negative 4t us of t. Now what is the Laplace transform of these functions? We're going to find these. Okay, the Laplace transform. Okay, you look at here. This is a function times us of t. Actually, this kind of thing sometimes confused, because you think, okay, we have one more function here, but you just should remember what is us of t. Us of t were equal to 1 or 0. For positive t, it is 1. For negative t, it is 0. Right? And positive t, and also t is 0. This is also 1. So this is us of t. So when you times us of t on some function, for the positive t, or the positive t, this is just 1. This is just 1. So it's just nothing. Right? Times 1 is nothing change. So it is just 3t e to the negative 4t. So we have this 3t e to the negative 4t equal to 3t e to the negative 4t us of t. They are same thing for t positive. Right? You should remember this. Alright. Okay. Now we want to find the Laplace transform. We check table firstly. If we can find it from the table, that will be great, right? Okay. Go to the table. We have two tables. This one. Find it from here. Can we find it from here? It's a t times e to the some power of t. Okay, it is here, right? T to the n times e to the negative at here. N is 1. Now we have n is 1. Large. Now n is 1. T to the 1s, it is just t. Then times e to the negative 4t. Right, this is our problem. And the result is this one. We need n factorial in the numerator. Now n is 1. And the denominator here is s plus a with the power n plus 1. Now n is 1, so here is a 2. Okay. So our, just by table, f of s equal to, this is I have 3 here, 3, then n factorial, 1 factorial, it is just 1, and s plus a, now a is 4, here is n plus 1, so it's 2. Okay, so the result is 3 over s plus 4 squared. That's it. So this is a simple one. This is simple one. You can find the answer directly from the table where it is this one. Oh, we also have this one. Yeah. We can use both. This is a t to the t times e to the negative at. Then it's 1 over s plus a squared here. Okay, we did this one. Yeah, you can also use these for n equal to 1. Yeah, this is more generalized. Okay. Here, no us of t, no? You see, in the table, no us of t. Yeah, but you can use it because, as I explained, us of t is just 1 for positive t. Okay, so this is one example. Now look at the second example. Example 1, example 2. Now f of t equal to 3t e to the negative 4t. Okay, it's a little complex. I start from the simple one. F of t times equal to, now is a t, just t, okay. T times us of t minus 2. Okay. Now the thing is a little bit different. Here I have us of t minus 2, not us of t. In the first example, here's the us of t. Now is the us of t minus 2. In this case, you cannot just consider this is 1, because this is not exactly 1. This one, us of t minus 2 equal to, it is still 1 and 0, for t minus 2 positive and t minus 2 negative. You see? Here's t minus 2, t minus 2. Then you can write it as 1 or 0. Its value either 1 or 0. Which case it is 1. Is t larger than 2, right? T larger than or equal to 2. Here's a t smaller than 2. So for this function, for t less than 2, it is 0. So when you calculate the Laplace transform, we know the Laplace transform, we have an integral from 0 to infinity. Now from 0 to 2 and from 2 to infinity, they are different. 0 to 2, this function, it is just 0. And from 2 to infinity, it is some non-zero values. Alright, so you should know things are different. Okay, so how to find the Laplace transform of this kind of thing? We still use the table, but we cannot use table directly. Actually, we have this one, right? Function t, we will have 1 over s squared. But now it is not t. It's t times us of t minus 2. You can figure out what's the difference? T and t looks like this, right? And the t times us of t minus 2. For here's a 2. Suppose here's a 2. T equal to 2. For t less than 2, it is 0. And after this, it is t. This is t. Right? Yeah, this is t. But t times this one. So when t is smaller than 2, it is just 0. So you see, these two functions, this one and this one. When you calculate by formula, you do integral from here to infinite, or from here to infinite. Obviously, they are different. Right? They are different. Okay, then how to do it? Of course, you can use the definition, but we can also use a table. We have second table. One of the properties just used for this case. That is a shift in time. We have this one. You see? We have this one. Okay, let me copy it in my notes. Laplace transform of f of t minus some capital T times us of t minus capital T equal to e to the negative capital T s f of s. I just copy it. This one, shift in time. I just copied in my notes here. Okay, I copied it here. I will apply this one on this function. Now you compare with this function, given function f of t, and this property. You can see the property, we need some function f. Okay, this is different f, alright? So this is the f in the formula in general. And here, this f is, given f is a fixed f. Okay, special f. We study this f. Okay, for here in this formula for this f of t minus capital T times us of t minus capital T equal to this side. This is I have fs times e to a negative t of s. So here is we need to rewrite this given function in terms like this way. It is a function of t minus capital T. It is not function f of t. It's t minus capital T, then times us of t minus capital T. Well, now capital T is 2, right? T minus 2, t minus 2. But here you see, here is a given function, here is a t, not t minus 2. We want to change this to be t minus 2. Okay, so we can work like this. Now, f of t, which is t times us of t minus 2. I want to change this to be t minus 2, so this equal to t minus 2. But they should be equal, right? How can we make these two equal? I need plus 2 again, right? We have this. Okay, you see this one? This part is that ft. Oh, okay, two things is confused. I gave a little bit change. I put this with f hat here. This capital F hat. Okay, so this is a f in the formula. This is a function we need to study. We need to study this f, and the formula is here. Okay, now what is f hat? So this is f hat of t minus 2. Yeah, this is f hat t minus 2. And then what is f hat? So equal to what? This is t minus 2, so this is t plus 2. Make sense? F hat of t, we replace t by t minus 2, we get this part. F hat of t, replace t by t minus 2, we get this one. So we have f hat is this one. And then by Laplace transform, capital F hat s. This will equal to, okay, t give us 1 over s squared, and 2 give us 2 over s. Okay, so here we're equal to, we use this formula. It is e to the negative t, okay, capital T, not capital T, 2, so negative 2s, right, capital T is 2, negative 2s, and f hat is, capital F hat is this one, so times 1 over s squared plus 2 over s. Okay, we're done. Alright, so when you have us of t with some shift, you need to work like this way. You need to work like this way. You rewrite this part in terms of a function of t minus capital T. Here's a t minus 2. Then you can have something looks like this, and use this formula. Alright. Okay. So this is the second example. And the third one, we consider something with a sine function, like f of t equal to, I still use that as 3t, but now is a sine of 2t times us of t. Well, first of all, this us of t, it is just 1 for all the possible t, so we can just think this is 1, right? This is 1. For positive t, this is 1. And this part, we try to find it from the table. Do we have terms with t times sine? Now this side is all of them are polynomials and exponential power. This side we have sine. We have sine, but before this sine, before this cosine, before this sine is a constant, before this sine is a constant, before this sine is exponential power, before this sine is exponential power, before sine exponential power. Well, sorry. You see, we cannot find it directly from the table. All the terms with sine, before the sine, no t directly, right? Some exponential power or some constant. But now we need a t in front of a sine. Okay, so how to do it? Well, we use Euler formula. We have t in front of exponential power, right? We have this. And a sine or cosine can be written in terms of exponential powers by Euler formula. So here we use Euler formula. By Euler formula, we have e to the I say ja equal to cosine of a plus j sine of a. Then we have e to the negative ja equal to cosine of negative a plus j sine of negative a. Then cosine is an even function, so negative a, cosine negative a, just cosine a, and the j sine of a is a negative sine a, so here is a minus. So we have these. Alright, we have this one, we say this is equation I, this is equation 2i, 2. The I, we want sine, right? We want t. We want a sine. So sine can be written in terms of these two. I just use I minus 2. 1 minus 2. This one minus this one. What happened? E to the ja minus e to the negative ja, and this one minus this one, equal to this one minus this one. Cosine, cosine, subtracted, cancel, this is 0. And j of these minus j of these, here's a negative, so actually 2, right? So this is 2j times sine of a. Right? Okay, now we have what is sine of a can be written as 1 over 2j times e to the ja minus e to the negative ja. Yeah, you can remember this formula. We use this formula every time when we have a sine. And as well as a cosine, we have similar equation, which is 1 over 2, here is e to the ja plus e to the negative ja. We have these two. They are also Euler formula. So Euler formula, we have two sides. One side is write the exponential power with imaginary these powers in terms of cosine and sine. Another side is write sine and cosine in terms of exponential powers. Okay, now we use this. Here, this sign can be replaced by two exponential powers. And the exponential power times t, we can find it from the table. Right? We just use that term in the first example. Right? In this first example, we just use it, right? T times the exponential power. Okay. Now we apply these here. So f of t equal to 3t times sine. Now is 1 over 2j times exponential power e to the j a. What is a here? A is 2t, right? A is 2t. So j times 2t minus e to the negative j times 2t. Okay, so we have these, right? We have these. And then us of t, we can just treat it as 1. So you don't need to write anything. Okay, so this is 3 over 2j t times e to the j 2t minus t times e to the negative j 2t. Okay, now we can use the table. We use the table equal to 3 over 2j, constant, I just keep it. And t times exponential power, that will be s. Here's a, okay, if here's a negative a t, here's a plus a, right? You can check the table. Here's a e to the negative a t, then here's s plus a. So now is e to the negative, e to the positive 2j, here will be minus 2j, right? A is negative 2j, right? A is negative 2j. So this one, e to the j2t equal to e to the negative at. That means a is negative 2j, right? Negative 2j. So this is a s plus a plus negative 2j. Yeah, it is this one. And 1 over this with a square. And second term, the minus this one, similar with the first, but just this, now a is just 2j. Here's a negative, then a is just 2j. So this 1 over s plus 2j squared. Okay, almost done. We just need to do some simplify. I have two fractions, then I can put them together. Right, so 3 over 2j, keep it. And combine this fraction together with times denominator. So it is s minus 2j squared and s plus 2j squared. And the numerator is this one, s plus 2j squared minus s plus negative 2j. Actually, I can write it as a minus 2j. Okay, it's fine. Squared. Alright. Then this is 3 over 2j. Numerator square of this, it is s squared plus 2 times s times 2j. So this is 4js. And plus square of this. Square of this is actually negative 4. Right? J squared is negative 1. 2 squared is 4. And the minus, okay, this is s squared. And okay, here's a negative 2. Right? Times 2 is negative 4. Negative 4js. And square of these is negative 4 again. Same with this, negative 4. Right? Okay, this is numerator. And denominator, I can write as a square of this one times this one. So I have s squared plus 2js, right? S times this term. And minus 2j times s, and minus 2j times 2j. It is 4j squared. J squared is negative 1, so it's negative, positive, right? Alright, this is this. Keep working on 3 over 2j. Denominator, these two cancel. It is s squared plus 4 squared. And the denominator is this one. Numerator, s squared cancel. This is a 4js minus negative 4js, so this is 8js. And plus negative 4 and minus negative 4, they cancel. Okay, that's it. Then this j and the j cancel. 2 and 8, that is 4. 3, 4 is 12 over s squared plus 4 squared. Okay, this is our final answer. Yes, for the simplify, we need several steps, but finally you can see this one is not too complex. I believe in some tables, I just use the table, Laplace transform table in our textbook. If you search online, maybe there are some Laplace tables. You can have these directly to get this one. Yeah, t times sine something, you can directly get this one. And now it's fine. We do not have that, then we can work in this way. Yeah, we do not have that in table, but we can calculate in this way. Alright, here the key tool is this Euler function, this one and this one. We can write sine or cosine in terms of exponential powers. Okay. This is an example. Now we consider another example. This is which example? Okay, we start again. Example, now we consider we have a function, we have several unit step, but with different capital T. Remember, we have that example. Yeah, we have example like this, right? We have us of t minus 2 here. We consider some more terms like this with different t, this capital T, right? Here's only 2. Then what do I have? Like this. So f of t equal to 0 for t for t negative or t between like 1 and 2, between 1 and 2, or t larger than 3. So I want the function looks like this. For negative side it's 0, and 1 to 2 it is 0, and larger than 3 is 0. And here in these two intervals, they have some different values. For example, I have like this one and this one. Here's 1, 2, 3. Here's also 1. Okay, I change scales. Oh, here's 2. Like this. Okay, so here's a ramp, right? Here's a ramp. Ramp slope is 2. So this is a 2t. Right? Ramp t is a ramp, right? 2t. Slope is 2. This is for t belong 0 and 1. I can also, I can write in this way or write in this way. T between 0 and 1 is 2t. Okay. And here, this is right this way, it will be a slope with negative 2, right? It's also ramp. And this ramp, it is a t. It is a t. But the 0 point, you see, here's the 0 point at an original point, so it is just t. And this one, original point, is not an original point. The 0 point is at t equal to 3. So you write here should be t minus 3. Yeah? T minus 3 is a ramp go across t equal to 3. Because when t equal to 3, this is 0. T equal to 3, this is 0. So the curve will go across this point. And its slope is negative 2, so it looks like this. Alright, okay. This is a t from 2 to 3. So largest 3 is 0, so here can equal to 3. And smaller than 3, okay, here this means 1 smaller than equal to t, smaller than equal to 2. Right? So here not equal. Here not equal. Alright. So we have f of t looks like this. Then what is we want to find Laplace transform of f of t, which is fs. We want to find this one. Alright. Okay. Now how to do it? We work like this. You look at the graph, the function. So for this case, for this kind of problem, if you only have a formula to describe the function, you need to give the graph first. Now I already have the graph, right? So we can just use this graph. You check the graph. It starts from 0 and then jump up to be a ramp. So this is a t times us of t. Actually this is this one, right? T. Here is a t equal to 0. For negative t it is 0. For positive t, this is 1, so it is just t. And now here is t equal to 1. After 1, here will go to 0. Right? Here is 0. Here is 0. So we need a t u s of t. How to go to 0? Now we have two things. One thing, this ramp will not have ramp anymore. After t larger than 1, we will not have ramp. We will have 0. It's a flat one. It's not a ramp, right? And also, the value here's 1. Right? Here's 1. Here's some value. We get 1. Now, oh no, it's not 1. It's 2. Sorry. Here's 2. Here's 2. Here's 2. And the value will not 2. It will go to 0. So here we have two options. One option is two operations. One operation we need to make the ramp go to here, and the second option we will move this, pull it down. The whole bar will from here going down to here, right? Okay, so we need a minus a ramp. That is a t minus 1 and us of t minus 1 with slope 1 with slope 2. We need to minus this. After minus this ramp, the slope going down. Yeah. Now after minus this, we get this line, and then minus here's a step, right? Just put it down. So minus 2 times us of t minus 1. Okay, because this is a t equal to 2. This is a t equal to 1. This is us of t minus 1. We need to minus this, right? This is the negative side. This is a positive ramp, a positive step. You need a negative step going down. So we get this one. So this one, what it is? Negative side is 0. Between 0 to 1, it is a ramp with slope 2. And after t equal to 1, it's going down to be here. Look like this. Look at this. But we need more, because after t equal to 2, we have this one. So here the value will jump up. Here will jump up to be like this, and with a negative ramp. So it is t us of t minus 2 t minus 1 times us of t minus 1 minus 2 us of t minus 1. This is this one, right? And here we need to jump up to 2. So plus 2 us t minus 2, because the jump happened at t equal to 2. These two are different. You see, this ramp, this step happened at t equal to 1. Jump down at 1. Jump down by 2 at time equal to 1. This is jump up by 2 at time equal to 2. So go to here. So after I add this term, I get signal looks like this. The value go to this. Now I need a ramp, negative ramp, right? So negative, the slope is negative 2, and the ramp will be t. Now it's happened at 2, so t minus 2, and us of t minus 2. So after this, I get this one. I get this one. Right? So it looks like this. Okay, like this. Here's 2, here's 1, here's 2, here should be 3. Alright. We know what is our functions look like this, right? This I still have something different. So this part I need to make it so no ramp, no more ramp. It's just go ahead straight, just smoothly. Right? So this one we're going up. So here I need to add. This is negative ramp. I need to add a positive ramp. So finally I have f of t equal to f of t is given one. Is this one? Right? F of t will equal to, copy all of these and add one more ramp here. So it is t us of t minus 2 t minus 1 us of t minus copy this 1 minus 2 us of t minus 1 plus 2 us of t minus 2. Alright? More. Minus 2 t minus 2 and us of t minus 2. And I need to add this ramp. So this ramp, is now is negative 2, so I need a positive 2 ramp to cancel this ramp. So plus positive 2, and this ramp start at this 3 times t equal to 3. So here is a t minus 3 times us of t minus 3. So okay, now we are good. We have the function looks like this. Alright, then next step will be simple. After we have all of these, we can have the Laplace transform f of s equal to, just check the table. This one will be 1 over s squared. This one, it is still 1 over s squared with a coefficient negative 2 in front of it. And also we need the exponential power negative t is capital 1 times s. Capital T is 1, not T is capital 1. Capital T is 1. Alright? And minus 2 is a unit step. Unit step is 1 over s. And here's T minus 1 shifted by 1, so e to the negative s. Right, we still use that property. Remember? This one, right? We still need this one. Some f hat, this is still f hat, and shifted by t, so here is e to the negative ts. Right? Yeah. So the first term, second term, first term is these, second term is these, third term is these. Okay, the fourth term, this one. I need a plus 2 times, okay, this is step. Step is 1 over s. The step happened at t minus 2, so e to the negative 2s. And minus 2, here's a t, is a ramp, so it's 1 over s squared. And the ramp happened shifted to t equal to 2, right? T equal to 2, so e to the 2, negative 2s. Okay, we have these. And last term is plus 2 times, okay, this is a ramp again. It is 1 over s squared. And the ramp is shifted at t equal to 3, happened at t equal to 3, so e to the negative 3s. Alright, almost done. The next step is to do some simplify, if we can merge some terms together. Can we? We have s squared e to negative s, negative s, negative 2s, s squared, negative 2s, 2s squared. Okay, each terms are different. Yeah, we have some terms both contain e to the negative s, right? So I can combine this together. Yeah, you can consider a different way. Like you can combine these two together, s squared, this together. Oh, this is also s squared. Yeah, I can put all the s squared term together and the s term together. Then you can have one way. You can also put e to the negative s together, e to the negative 2s together. Then this one. Yeah, I can just keep it. Yeah, it's fine. Yeah. Alright, to do some simplify is also fine. But it seems this one, the simplify is still not really simple. So okay, just keep it. Right. Yeah, any problem? No problem. Yeah, even you have problem, you can we can discuss later when we go back to classroom. All right. Okay, this is one example. And similar problem, we can consider even longer, even complex signal. Here we have, okay, like this one. We have f of t, which is period. period. Here's 1, 2, 3, 4, 5, 6, and here value is like 3. Alright, 7, 8, and so on. Okay, now what is the Laplace transform of f of t? Okay, so this time, of course, we need to write it in similar way with these, and then each term can use the table and the properties. Okay, so this one, f of t, it start as a ramp, slope is 3, so it is 3 t us of t. And at time t equal to 1, the ramp will be cancelled, no more ramp, right? Here the slope is 3, then tend to be slope is 0. So we need a minus 3t, but now the slope happened at t equal to 1, so t minus 1, and us of t minus 1. So after I minus this term, I get this one. This is flat one, right? Okay, just keep it until t equal to 2. It's going down to be 0. So here I need a minus 2, not minus 2. Here's a minus, jump down by 3. Right? Here's a 3. T is 2, but jump down by 3. So it's a jump by 3, and the us of t minus 2. Yeah, so here from this point we go down to this point, right? From 3 to 0. So we minus this. But after I'm going down, this is also a fixed value going like this way, no slope, right? But I need a slope here. Slope is 3 again. So here's a plus 3. Slope is 3 times t. Now t minus 2, because this ramp start from here, and the us of t minus 2. So we go to here, right? Go to here. And then similar here, we need to cancel the ramp again. So minus the ramp, this is 3, now minus 3 times t minus, now we change this slope here, right? So it's minus 3, t is 3 here, and the us of t minus 3. After I cancel this ramp, I get this part. Okay, next things change at time equal to 4. So I need a minus at time equal to 4 minus 3, right? Jump down by 3. So it's just jump down by 3 times us of t minus 4. And then I need to add the ramp, still at a time equal to 4. So the ramp slope is 3, and t minus 4, and the us of t minus 4. Now we go to keep going here. This one goes down, I'll go to here. At time equal to 5, we will do similar thing. We need to cancel this ramp, so I need a minus 3 t minus 5 us of t minus 5. Okay, so we get this one. And then at 6, minus 3 us of t minus 6, they're going down. And we need a ramp, so plus that ramp is 3 t minus 6 us of t minus 6. Alright, keep working with the same way, right? Same way. Okay, now we can have the Laplace transform. Laplace transform, we have f of s, which is, we just change them term by term. The first one is a 3 times t us of t, that is 1 over s squared. Second term is a minus 3 1 over s squared with e to the negative t, right? Negative s, negative t times s, but capital T is 1. Capital T is 1, so negative capital T s, just negative s. Next term is a minus 3. This is a unit step, right? So 1 over s, and shifted at 2, so e to the negative 2s. Okay, I have this one, this one, this one, this one, this one, this one, 3. 3 terms. The fourth term is plus 3. Here's a t. This is ramp, right? T times us of t is 1 over s squared, and shifted to t equal to 2, so e to the negative 2s. And then I have these minus 3, 1 over s squared, e to the negative 3s. And, okay, similar thing, right? Minus 3, 1 over s, e to the negative 4s. And plus 3, 1 over s squared, e to the negative 4s. And here, minus 3, 1 over s squared, e to the negative 5s. And minus 3, 1 over s, e to the negative 6s. And plus 3, 1 over s squared, e to the negative 6s, and so on. Okay, and so on. Okay, this one is off. We have these. Do some simplify, can we? Yeah, this part, you see, these 3, this column, these 3, and we will have more. They are quite regular. We have 3, 1 over s squared times exponential power. The power is negative 2, 4, 6, and so on. And this one also similar. 3, 1 over s, 3, 1 over s, and the exponential power, this one, this one, this one. Same with this. And this one, 1 over s squared, e to the negative 1s, 3s, 5s, and so on. Okay, so it's write this way. 3 over s squared, the first term. And second term is minus 3 over s squared, and inside is e to the negative s plus e to the negative 3s plus e to the negative 5s plus, and so on. So the power will be 1, 3, 5, then 7, 9, 11, already odd powers. Right? Is this column. And this one, minus 3 over s. Here's e to the negative 2s plus e to the negative 4s plus e to the negative 6s plus, and so on. And this one is plus 3 over s squared. 3 over s squared times e to the negative 2s plus e to the negative 4s plus e to the negative 6s plus, and so on. All of that, right? And, well, these two can combine together, right? These parts are same. And these two are same. Maybe I can put 1 minus all of these. Well, here we can, you see, this one, all of them, we can use that formula. 1 plus a squared plus a cubed plus all of them equal to 1 over 1 minus a. Yeah, like this, right? So we can use this one. So, okay, this equal to 3 over s squared minus 3 over s squared times these. The first term, after I remove this e to the negative s in front, this is 1. And then e to the 2s, e to the negative 2s, e to the negative 4s, e to the 0, e to the 2, e to the 4, e to the, here will be negative 7s. Move 1 out will be to the 6. So it's 1, 2, 0, 2, 4. Okay, so this is just the 1 minus that a is negative 2s. Right? It's 1 plus e to negative 2s plus e to negative 4s plus e to negative 6s plus so on times e to negative s. Right? This one. is this one. Okay, and the second term is minus. Okay, I say these two, they have same this part, so I can combine these two together. Is a minus 3 over s minus 3 over s squared, right? I put minus in the front, then this one I need one more minus, more two negatives positive, right? So this one, and this part I move e to the negative 2s in the front. So this will be e to the negative 2s times 1 plus e to the negative 2s plus e to the negative 4s plus, and so on. Right. So this part is this again. So this is 1 minus e to the negative 2s is 1 over. Okay. Then this one can be right somehow shorter at least, right? Minus this term and this term the same, and this term you can move one of these, right? Here's a 2, here's 1, so this is 3 over s squared. I put plus, here's a negative, okay, and this one move out, this one move out, so the first term just have these, and second term, oh, this is minus, okay, just minus, here's also minus, then this will be plus 3 over s minus 3 over s squared times e to the negative s, and this one move outside, is moved outside, and this one also moved outside. Okay, like this. This is shorter, right? This is shorter, of course shorter than this. This is infinite summations. Now I have finite summation. This one is shorter than this. Okay. So the final answer, you can put it like this. Put it like this. Alright. Yeah. Okay. That's the end of this example. Also the end of this lecture. I have a little bit more time. Okay, it's fine. Okay. That's all for today's class. Then see you on this is a Friday, right? This is Friday, and Monday is a holiday, and Wednesday, suppose Wednesday we can go back to the classroom. I don't know. In case if the weather condition is still not good, then we will have the class online in the same way as today. And if the condition is good, the weather is good, then we go back to the campus. Just pay attention in the Blackboard. I will tell you if if we will keep working online or go back to the classroom. Okay. See you. Bye bye. Have a good day. Keep safe. Keep warm. Alright. It's a really winter day. Okay. Bye bye.